That means I spend a lot of my time with developer and with project people that are trying or starting project with NoSQL database, with Couchbase in particular. And we decided to do this webinars based on the experience, on the different questions we had from this different experience. So the way it's organized, this presentation is organized, is explaining quickly why it is interesting to look at NoSQL and moving to NoSQL from your relational database, and what are the key differences between RDBMS engine and Couchbase. And more later on this, we will try to explain how to move. And as part of this, it's about modeling the data, accessing the data, migrating the data. And during the migration part, I will show you a demonstration using Couchbase and different tools that are made to help you to connect or migrate your data from your relational database to Couchbase. So do not hesitate to go to our download page, download Couchbase, take a look, easy it's to use, install the product. Few minutes to do that. So the first question to ask is why people are looking at NoSQL today. And you have various questions or various answers to that. But if you look, a very short answer will be because we are building an application and we want this application to be successful. And most of them are using a database behind. So you have to deal with a lot of data and a lot of users. And most of them today are still using relational database. And you may have more complex schemas than this one, but this one is still already complex. So as a developer, as a DBA, as a system administrator, what you have to deal with is your data is coming, your database is getting bigger and bigger, even so big that you cannot use it anymore, you cannot manage it in an easy way. So one of the goals of moving to NoSQL is to deal with the size of the database, but also the complex part of it, the complexity of dealing with a very large relational database. We have to see that in from 2 points of view. One of them will be purely the size of the data. And if you look at the way relational database has been built, it has been built to scale vertically. You need more power, you need more storage, you have to grow your server. You have to have bigger hardware. But it's also, we can also talk about scalability and performance. If you want to distribute the load on multiple machines with relational database, you can, yes, create cluster, but it's something that is very complex. You need we need DBA with a lot of expertise, with a lot of experience, or you need to put a lot of code inside your application to deal with the distribution of the data on multiple nodes, where NoSQL database like Couchbase have been built to deal with the distribution of the data on many machines from the beginning. And distribution should be simple, so you should be able to manage the scalability of your data, but also we should keep the performance and the latency to access your data very good. And if you look at, we did a survey a few months back where we asked the people that are in our community, why did you switch, or why are you using a NoSQL database? And most of them have used about 2 main reasons. The biggest one is about the lack of flexibility, the fact that relational databases have rigid schemas, so it makes the life of the developer on upgrading to a new version of your application quite complex. And the other part is inability to scale out the data. And I will say that more than inability, it's the fact that it's hard and it's expensive compared to do the scalability to deal with scalability with Couchbase. So in the landscape of all the offering you can see on NoSQL engine, obviously today I will focus on Couchbase, that is a document database. And I will explain now why document databases are very interesting to work on build application, and how you can use your experience with relational database inside a new type of application database like Couchbase on how to migrate your data and your application code. So I quickly introduced some part already of the differences between relational database and NoSQL. Two of them being how we deal with scalability, how we deal with performance. So we distribute the data on multiple clusters, on multiple nodes on the cluster, and by accessing by subset of the data on different nodes, we make it more efficient, and we can deal with more data, and we can deal with more users without impacting the performance of your overall system. But another part that is very important, and that has a bigger impact on the application design, the work of the developer, the way you build your application, is the fact that inside relational database, as the name says, we use relational data. We use a relational data model based on tables that have relation between them and some very strong constraint on the schema that has been rigidly defined before creating the data. You cannot insert data inside a relational database until you have created a schema that defines the type of data you want to insert into. Where the document data model, that is what we use inside Couchbase, has been able to create very complex data set if you want, but with documents that you can deal with any type of schema or format. You can have in the same document multiple information like a product, the comments on this product, the tags that you will have. You will put that in a single document. You can put that in a single document. But also a very interesting difference between JSON and relational database is each record is a document, but each document is an independent from the other. That means you can have not only complex document, but also two documents that define, for example, a product could have a different set of attributes. And it could look odd when we think about it from a relational point of view. But let's take a concrete example. If you are creating a product catalog and you want to expose this product catalog in your application, a product could be defined by many types or many attributes that will first be different from one product to another, and could have a specific data type. I like to take as an example, suppose I am selling sports gear I'm selling bike and clothes. If you look at the bike has a size, but the shoes and the t-shirt has a size. But the attribute size on the bike will be the size in centimeter, for example. The size of your shoes will be another integer. The size of the t-shirt will be small, large, or X large, for example. So, and you will have different attributes, like for example, in the type of the bike, you will add some information about the number of gears, the size of the wheels, and this kind of stuff that has nothing to do when you compare with a t-shirt or a shoe. But all of this is a product. And it makes a lot of sense from a development and a design point of view to put that in a single document. When you want to do that with a relational database, you have to make complex schema design choice that makes the life not that easy for the developer. Or you have to use the relational database as a simple key value store. That is not why it has been built. In addition to the pure design point of view, where you can have this flexibility, we also allow people, the server side will allow automatically the system to distribute the data evenly on the different end of the cluster. It's very easy to do when you have a document to say this document goes on this node, this other document goes on the other node. So you distribute the load, you distribute the data, and if you need more power, if you need more space, just add new node to your cluster. Also, inside Couchbase, we choose to work with JSON because, like that, first you have a definition of the data that your application can understand. So the schema itself, it's not defined inside the database, it's defined inside the schema on the application. So your code, your developer know how to deal with it. But also, because you have specific attributes, and these attributes have a specific meaning, you can query the documents based on the attributes. So you will create index, for example, of the name of a product or the type of the product to be able to ask your database, give me all the bike or give me all the shoes that I have inside my system. So if we look more into the detail of how do you design stuff and how you will do in one case or the other, in your relational database, we have been focusing on creating tables and link between different tables. For example, if you want to create a user and define the address of the user, the good practice will be to create two tables, make a foreign key between them, and when you want to look for the information, you do a join between these two tables. If we look the way most of the time you will design your documents in your application, you will do an aggregate of that. Meaning in one single document, you will say, okay, not only I want the user info, but I want also to add the information about the address inside the document. All this will be in a single document. It's not necessarily always like that, but this is most of the time the way you start to design your data and your documents. And it makes sense for something that is quite interesting. It's what happens when you want to upgrade your application. You have to add new information inside your records. You want to have new attributes because you have added new feature. For example, in this case, I want to be able to add the country to different tables. So you have to create the tables, you have to alter existing tables to add a specific field and foreign key on your running application. So first of all, it could be quite expensive to do. And when you do it, you have to do it on all the records. You have to set a null value and this kind of stuff. Depending on your server, you could even put some lock on your database or specific record when you are doing that. So you may have an issue with the availability of your application or your database for a while. This is one of the reasons today in many applications, people are not upgrading quite often their schema. It's not because they don't necessarily have the business need, it's because they are worried of updating the schema, the impact on the application, on the database. In the other hand, when we work with documents, it's quite easy. You take the document, you add some attributes. And yes, you can do it using a small routine on all the documents, but most of the time what we see people doing a lazy migration of their data. It's only when they access their data, they look if the documents needs to be upgraded to a new schema, and they do it. Why does it make sense to do this stuff? It's because if you look at the type of application you can build, let's say, for example, a social gaming or a social betting system. When you launch your application, you may have few users, and a few months later, you may have millions of users. But on this quantity of users, maybe only 10 or 20% of the system, of the user are using your product on a daily basis. It does not necessarily make sense to upgrade all the 10 million of users only if you have 1 million of users using your system, so you don't consume any resource until the user is connecting to the system, where your application will automatically upgrade and apply some schema change to the document. So you consume less resources and you only do it when it's needed. It's really you as a developer, as a system administrator, you have the choice of dealing with the upgrade or the change in your schema. So it's interesting, I took some example, but to look in which type of application NoSQL is really a good fit. And for this, I will simply use a list of projects or customers that we use with Couchbase. So obviously, we have many internet companies type of projects that has been using NoSQL database. Social gaming, ad networks, social networks, e-commerce platform, online media. But also, NoSQL is also a big adoption in enterprise like communication, financial, not necessarily for the same type of use cases, but for the same type of reason, flexibility and scalability. So let's take some concrete example based on some of the customers we have. In the internet companies, for example, you have Orbit's online booking system and hotel reservations. that will allow to use Couchbase to store a part of their metadata inside our engine. Zynga, social gaming, we had a good story with OMG Pop, Draw Something game, where they moved from 0 users to 50 million of users in 6 weeks. So how do you deal with this quick growth of the application? So they need scalability, they need flexibility. For the same reason, you will see in a telco company like Korea Telecom, like Orange, that will need a NoSQL engine to deal with specific data sets that they want more flexibility on the schema. For example, you will see that I work with a telco here in Europe that need to have to upgrade their product catalog, the type of service they sell to their mobile consumer or customer, where they want to be able to add more information about the different products they offer. It was very hard to add any type of value in their relational database-based application because they had no access to the product catalog. It was a built-in software that was bought. So what they have done, they create a subset of the data inside Couchbase, adding many attributes in the way the marketing and the product marketing wanted. Like that, they can expose more information to the user, having the flexibility on even adding more data, and depending on the service, have different view of the metadata they want to add. So how do you choose and how do you quickly see if you need or if Couchbase or NoSQL engine will be a good fit? A good example will be if you have to deal with third-party data that are more or less structured, but more importantly coming from the outside. If you want to integrate Twitter feeds, if you want to integrate with Facebook data and this kind of stuff, you don't control the data. The data could change over time, and the data are quite complex. I invite you to look, for example, at the Twitter API to see how big is a message in Twitter. It's 140 characters in the message, but the Twitter API has probably 140 attributes inside the JSON document that sends you back. So if you want to store that, it's good to be flexible. It's good to be able to store any type of data. And if they change their API, you can do it without impacting your application. I talk about draw something with a very quick growth. Typically, if you have to move from 0 to 50 million, you need to be able to deal with the scalability and the growth of your database. It's better to be able to start with a small cluster, let's say 5 or 6 nodes, and be able to add nodes over time to be able to deal with all the user and data you have to manage. Talk about already the product catalog and non-homogeneous geostructure. And finally, when you have really you need a lot of flexibility to the data structure. You change quite often, you add new type, you have different size of document or data. It makes sense to use JSON document. So Couchbase is a good fit when you have this kind of requirement for your application. And very often we see that people that are using today a relational database looking at NoSQL because one of these points, it's becoming an issue in their existing database. If they start to aggregate data coming from different systems, and the structure is complex, they cannot create one table for each data or for each API call. So it makes sense to do that in something more flexible, for example. At the other hand, we also have another approach to see that when Couchbase will be a good fit. If you really need a very, very fast access to your data, either because you want to be able to control in a predictable way how fast you will access your data. I want to be able in my application to access the data in less than 1 or 2 milliseconds. And I want that to be always the case. And I want that if I have 2 nodes in my cluster, or even in a month from now when I will have 10 nodes because my application is very successful. Or you have many, many operations per second. For example, 200,000 operations per second, with 10% of these operations being new creation of documents. You need to deal with large number of users. So typically, this is the type of questions you may have in your application, and you want to be sure that your database will scale and will answer this specific requirement. This is where also we see Couchbase being very successful. predictable performance on latency and be able to scale. Typically, if you look at your relational database, it will ask you a lot of work if you start with a small data set on a very large data set and guarantee a very low latency access to your data. Because it will be hard to distribute the data on multiple nodes, because it will be expensive to do that in terms of how do you manage a cluster of your database, where it's something that is natively built inside Couchbase. So just as a reminder of some type of application we have built with Couchbase, or our community and customer have built, social gaming to store player and game data, mobile apps, so be able to have a backend that is storing the data, the application of application content. You probably have seen last week we announced also a more global strategy over mobile to have not only the cluster on the server side available in your back office or on the cloud, but also provide the same NoSQL JSON-based database inside your mobile and provide the synchronization, because mobile is a big success for NoSQL database. Ad targeting, and this is very simple to understand. A very large volume of data. You have billion of users, billion of profile, and many campaigns on ad banner or videos you want to expose to a website. But this, you need to be very fast to make a decision based on the profile of the user, which advertisement banner I want to see. And when I say you have to do a quick decision, if you look at AOL or TubeMongol that provide advertisement banner or videos, overall, based on their contract they have with their customer or their partners, they have to provide this in less than 100 milliseconds. But this is over the internet, accessing their data center or Amazon. That means their application server needs to select the good data that describes the banner in less than 30 or 40 milliseconds all the time. So they need to be sure that the latency and the performance of their database is very fast to be able to respect the SLAs they have with their customer. Session store, less than a database, but more a simple key value that scale. User profile, so be able to store complex information about user using a simple key but a complex JSON document, and you can add metadata to the user. You start, for example, simple username, email. Later, the marketing wants to have more information about social network in this user, so adding the Facebook ID, Twitter ID, and more data. So different profile, but you want that also to be very fast in access and flexibility to the developer. A cache at the top of your database or existing application. Content store is quite interesting. We see that people first building at the top of Couchbase another database to store metadata and integrate with a full-text indexing system like Elasticsearch besides their main database, or creating all the content management system and the metadata of this content inside a NoSQL engine, inside Couchbase using simple JSON document. And I talked already about Twitter integration, for example, so integrate data from different sources. So some of the key benefits, we have seen that scalability and flexibility, some specific use cases. Let's see now how you do it and what is the impact for your team as a developer or as a system administrator, for example. The first part, and I think this is the most complex part. As soon as you get used to it, you want to use NoSQL all the time. But in the same time, because you are so used to relational database, SQL, and the way we design the schema of the database, document design is probably the most complex part. And the most complex part because you have so many options, and some example will be when you create a document that describes something, let's say a product or a blog post. You can put all the information in one single document, and inside this document to have many embedded as JSON objects. For example, you have the product itself and many comments about this project in one single document. It's great because you will denormalize the data. You can organize the data the way you want, the opposite of the way you do it in SQL. And it will be very easy to access the data. Single access to one document, you get all the information. But you may have some issues because if everybody is modifying the document in the same time to add new comments, you may have some concurrency access or contention to the document. This is why you have to choose between a one single document approach or separate the document in different objects. So you have less duplication of the data, but you will have to do multiple calls to get all the information. You may distribute the data on different nodes. And remember that today, inside Couchbase, like many other NoSQL databases, we don't support transactions. That means you cannot insert multiple documents in one single transaction and at the end say commit or rollback. Each operation will be atomic, so you will be able to save document 1, document 2, document 3. But if you have an error on document 3, or if you want to cancel that, you will have to manually delete document 1 and 2 if they are related to document 3. So this is the type of things that as a developer you have to think about. Let's take an example with the blog post that I mentioned before. So you will have user profile, but let's focus on the blog post and the blog comment. So the blog post contains the title, the content of the blog post, and the comments will be the list of comments associated to this post that has been entered by other users. And for this, you have the two basic approach to do that, where you use a single document when you have the blog post itself, then a list of comments in one single document. Or you create the document that contains the blog post, then a list of other documents containing a comment, each one containing one comment. How does it look in a JSON point of view? Is if it's embedded, you will have the author, the type, the title, the body of the blog post are attributes, and you have one attribute that is a comment that contains a list of comments entered by all the users. So this is great because you can get all the data in one call, but in the same time, it's dangerous because you don't control the size of the document. You don't know if a blog post will be only 2 comments like we have here, but if it's Hacker News, you can have hundreds of comments related to a specific blog post. So you may have a bigger and bigger document that will be slower to download to your application. This is why you may want to use another approach where you deal with another document that is linked to the main blog post. And when I say linked, it's something that you will have to deal inside your application using a new code or using some specific pattern we have with keys to say this comment is related to this specific blog post. In this case, what I use is the ID of the document, the main document, the blog doc. It's called Couchbase _hello_world, and I choose to call all the comment with a number underscore Couchbase _hello world. Like that, I can quickly look and search for specific comments, either by putting the list of the comments inside the main, or just by using the key pattern comment with a number, and look to give me the 10 first document, for example. In this case, we have more flexibility because every time a user wants to add a comment, it has no impact to the main document. And this approach with multiple documents also gives you some flexibility for your application. You may want, inside your page, to fetch only a subset of the comment. For example, you bring the blog post, and using an asynchronous call, you bring the first 10 comments. Then when the user scrolls down, you want to get back from 10 to 20, and so on and so on. So you will have more flexibility in the way you want to query the data. You have more flexibility in the way you want to delete or add new comments if you have created multiple documents. Obviously, if you want to delete a blog post, you will have to manually delete all the comments because we don't have delete cascade. But this is something you as a developer will have to manage, will have to deal with, and it's something that is becoming very natural when you start to work with document database. So let's say to try which one is the best. And I will say, this is a very usual answer, it will be it depends. It depends of what? It depends mainly of the way your application is using the data. And this is a key point, is if you look at the way you design your application and your database in your relational world, you don't even think about how you use the data. You just think about the data themselves as a standalone thing. I have an order, an invoice, and inside this invoice, I have a set of items. I will create two tables. Yes, it's great. This is how we have learned at school for many years. But in the same time, when you look at the way you deal with it inside your application, it's not necessarily exactly like that you do. When you create that, you create an invoice on items, but when you expose it to the page, it could be very useful to do that in one single call and put that in one single document. And because the invoice, most of the time, you will just read it and print it or send it by mail, the read is more important than the creation. It will make sense to put that in a single document. At the opposite statement that I've done on the blog post, when the comment is something you want to put in multiple documents because you want to add them and manage them independently of the blog post itself. So it's really dealing with the way your application is managing this data. How do you read? How do you create? Based on this, you will select a specific design. The way I do it personally, it's I try to start from the screen I have on my mobile application, my website, and this is the aggregate view of it will be my document I'm starting with. And based on the way I start to use that in my application, sometimes I will kind of renormalize it by moving from an aggregate to a multiple set of documents. And this is important to remember that changing the schema inside your relational database is expensive and sometimes complex. But changing the way you organize the documents, so the schema of your documents and the way they are organized together, it's very easy. It's only something you have to deal with your application code. And it's doesn't necessarily impact a lot your application. And do it most of the time on a lazy fashion. You do it when you need to, when you access a specific data you want to move. Before going to what you have to do in terms of code and migration of the data, I would like to take some time to answer some of your questions, if you have any.
Yes, thank you, Tag. So we have a lot of questions. We're going to address a couple now, but I know you have a great demo prepared for the end of the presentation, so I want to jump into that. So we have a good question from Robin. So NoSQL sounds very interesting, but if I want to migrate my backend infrastructure to NoSQL, do I have to migrate the whole infrastructure, or can I combine the two systems together?
So I will repeat myself like I did before. I will say it depends. It's another context, but it's the same answer. It really depends of your application. What we see quite often today, not in the context of startup, we're creating a new project, but when we deal with large enterprise, most of the time we deal with two types of backend. They still have their relational database, and they have a subset of the data, or all the data with some additional information in the NoSQL engine. So it's really based on the type of data you have to manipulate and which one do you consider as a main data store for your data. And I can take this example again of this mobile company where the product, the catalog of their services is inside a relational database, is inside their software that they have bought, and this is the main data. But they push the subset, not the subset, they push the catalog using a RabbitMQ, so using a messaging queuing system to a NoSQL engine in which the marketing team can add, using an application that has been built by the team, more data. In this case, they typically use two data stores. At the opposite of, for example, the betting system or social gaming, they have their main data inside Couchbase, where the user profile, where the game status is inside Couchbase, and only a subset of the data, like the payment and this kind of stuff, is pushed in the relational database. So most of the time, you will have an integration of multiple systems, but the data could be either in NoSQL only, relational only, or both of them. You just have to think, how do you synchronize when you work with the two systems together?
Perfect. Thank you, Tag. So another question, and then we go back to the presentation, but we will have another 10 minutes at the end to cover other questions. So how do you handle data redundancy in a document database?
So the question is a very interesting question and a very hard question to answer. Is if you start to aggregate data in one single document, you will for sure have a lot of redundancy. Let's take an example that we had at the beginning with user and their address. If you put everything in one single document, for sure you will have redundancy. In this case, you will have all members of the same family living in the same house, will have the same address all over the place. And if you want to change it, it will cost a little more than what you have today. So it really depends if redundancy is a problem for your application in the way you deal with the data. And I will try to take an example. First of all, I am sure that today, inside your information system, you already have a lot of data redundancy. When you create, for example, your data warehouse, you put a lot of redundancy in the data to make the application or the access to the data easier for the BI guy. It's the same here. It makes sense sometimes to have redundancy of the data. And it's not necessarily a problem. Does it a problem on an invoicing system to put the address of the customer in one single document? Not necessarily, because what you have inside the invoice, it's the address that you have used for a specific moment in time. It's not necessarily a real redundancy of the data. So it's really, if you need to change the data that is redundant quite often, try to create multiple documents and deal with the fact that you may have some non-transactional operation to deal with because we are not supporting transactions. So dealing with redundancy, it's not something that the database is doing. It's something that your application developer will have to deal with. And once again, it's really focusing on how do you use your data. And if you look at, if you capture, for example, information from Twitter, or take a look to Twitter, I would say the opposite way. If you look, all the messages inside Twitter contain the user profile. The user profile including the name, the picture, so the avatar of the person, and it's a redundant information. And more importantly, it's a redundant information that is not necessarily up to date. But is it a problem for my application? Not at all, because the way I do it, I don't necessarily need at a specific moment of time the latest avatar for the user, because for my business, it's not a blocking issue. So a different way of thinking about the data is the key.
Thank you so much, Doug. And I think we can go back to the presentation, but please keep asking questions. We will have more time at the end of the session to cover those questions as well.
So since today it's only a 1 hour webinar and we can spend an hour writing application, moving data on code, I will just give you the key steps when you want to migrate the data. I wanted to spend a lot of time on schema, on document design. This is what I have done. And let's now to see what are the key points when you want to write your application. Either create a new application or use your NoSQL database in an existing application that was using a relational database. I think the first interesting point to remember is you can hit the database as much as you want. And I'm saying that is myself, I am a Java guy, and when I used to work with Java EE and relational database a lot, we were always trying to find a way to cache the data on the middle tier, to cache the data inside my Java application to avoid calling the database, because it was one of the most expensive treatments on processing of computer or network that we had. Using Couchbase, you can hit the database as much as you want, because once you have the key, it's a very, very, very fast operation, and we do caching for you on the server side. So the first thing is, if you want to hit the database, don't hesitate. You just need to find a way to get the key to the document. And this is why we have created views, and I will come back to this in a minute. But first, from a code point of view, like any database on any storage layer, you have a way to find data, to save data, and to delete data. Once you are connected to the database or to the cluster, keep in mind that when I say the database in the context of Couchbase, it's one or multiple nodes, and it's transparent from your code. So when you are connected to your database, to your Couchbase cluster, you can do get with a key, set with a key on the value, or delete, and it will do the find or select by ID, the save or update, or the delete. So quite simple. And you have that in all the languages, or most of the languages, I would say Java, .NET, PHP, Ruby, Node.js, Python. So really a lot of freedom here in the way you want to do it. And as I said, all these operations are atomic. So when you do a set, you are sure that this document will be saved. You do a delete, you can check if it has been saved, it has been deleted on disk and this kind of stuff. But you cannot create a transaction with multiple operations. Also, something that we have to deal with a lot in web application, or when you have a very large set of users, it's concurrent access to some resources. And inside the relational database, in your application, even if you can put lock on a web app, on a very large set of users, you usually don't use a locking system from the database. What you do optimistic locking. This is exactly what we do, but we have pushed that inside the engine, inside Couchbase, using a CAS operation, or CAS being check on swap or compare on swap. It's a way that before saving the data, when you get the data out of the database, you want to modify them and saving back, we check for you if the document has been changed by somebody else. If it has been changed by somebody else, being another user, another thread in your system, we won't save the data and we will let you know that it has been changed. And now the user has to choose what he wants to do. Can he retry? Does he want to compare the result and save it back? But the thing is, on the server side, inside the Couchbase cluster, we don't consume any resource by doing that. This is how we can guarantee that we have the same latency even when you have concurrent access to the document for a write operation. So very basic operation to get and save the data in and out of the database. Also, I won't go in all the detail, but the developer can also choose to use an expiration parameter to say, remove this data from my database after 30 minutes, or after 30 days, or after a week, whatever you want. But once you have stored the data, for example, as a JSON document, you may want to find or search them using, as I said before, for example, give me inside my product documents all the documents that are bikes or that I choose. For this, inside Couchbase, you need to create an index. So you need to create a view that will analyze the JSON document and create a B tree and structure on this that allow you to query quick, very fast. And you can do index on the keys of the document, or you can create index on any attributes you have inside the JSON document, for example, the product type in this case. Then it allows you to do some queries with specific parameters. So give me all the bike on the shoes, or all the bike only, or give me all the product with a price that is between this and this. So doing some range queries, doing some keys queries. And a very interesting feature that is used a lot is aggregation of the data. Counting the number of products as a specific type, for example, or calculating the average price of a specific type of product in my JSON document. And we do that very efficiently by indexing the system as in an incremental way when you save and modify the data. So as a developer, for when you are migrating your application, you have to write some code or change the code to set and get the operation, the data in and out. When you have more complex queries to do some calculation, you can use views to do this and put some specific queries on specific field inside your JSON document. So the Couchbase view, it's based on a technology named MapReduce, where we analyze and create a map of the data, and we will be apply some reduce functions to do some aggregation. This is a screen that you use to test or develop the views if you want as a user. So one interesting point also is how do you do data migration? If you want to migrate the data, really moving the data because you want to get rid of your relational database from your SQL engine to your NoSQL engine, or because you want to duplicate the data to add some values and do that on a regular basis, you have multiple options to do that. what you have is you have to connect your relational database to your Couchbase cluster. And you can use many ways. You have many, many ways to do that. You can use ETL, so extract, transform, and load tools to do that. Create your own tools, create your own code. And what I will show you today is two ways of doing that. One is using Talent. Talent is an ETL, an open source ETL that allow you to connect to any relational database, but also many other data sources. You can even connect to an SAP system and push the data, transform the data, and push the data as JSON document inside Couchbase. And you can do that graphically inside their tool, or you can use a command line tool, for example, that has been written in Java. And I will show you both ways of migrating the data. So let's do it. So let's start with looking at my relational database. So I connect to the MySQL engine, and I have imported the world data set that is a sample. So show tables, you see I have different tables. They have a specific schema. So ID, name, country code, district, population. The country code is a link, is used a link between, as you can guess, table city and table country. And if I count the number of records I have here from city, oops. Sorry for that. World. From the city. So I have a little more than 4,000 rows in my table. How can I migrate the data from one specific database to another? So I have created a small tool in Java that allows you to do that from a command line. So I will start with this approach, just to show you a very simple way of doing it. So for this, I have another terminal. I can use a property file to define what I want to do. Connect to this specific MySQL engine instance, connect to my specific cluster in Couchbase that I will show you in a minute, and select which table I want to import. By default, Alt, and I will create some views to analyze the data automatically. So create index, for example, on keys or type of documents. Because inside Couchbase, you have the concept of, so I'm connected to my cluster has multiple nodes. So I was saying that inside Couchbase, you have the concept of bucket. So that is like a schema inside the relational database where you put all your data. But we don't have specific tables or specific collections. You put any type of document. And the best practice is to add a type inside the JSON document to show that is a city, that is a country, or that is a language. So let's do that using the command line tools that I have. So I run the Java command to execute the jar file. I use the MySQL JDBC driver to connect, and the property file that is defining the connection and how I want to deal with the data. So executing the information, so we'll read the data and create the views. So it has imported 4,000 and so on, so different views. So let's go now to my Couchbase console to see what's happening. So if I look now in my cluster, I see that I have 1,000 items or more on each node. Because it's a 3-node cluster, we have distributed the data for you. I move from a one single node MySQL engine to a distributed database on 3 nodes. And the documents, based on the logic that I have in my importer, I have created keys with the type of data. So if I look, for example, in country, and for all of this, I have the different field. And same if I want to look at a specific city, I can view the information. So the ID, the country code, the name, the district, and the population are the fields coming out of your relational database using the good type of data. You see, for example, an integer here. And the type is a field that qualifies a specific type of data that I have stored. If I look at city, type will be city. If I look at country, as you can guess, I add the type somewhere, country. This allows me to query the data based on specific attributes. So the importer tool creates some views just to show you how to do what you can do with it. So for example, I have a primary key, but I also have a view that lists for all the type of data. So for all the type, I will create a specific ID, and I can query that, for example, to count the number of documents for each type. So let's say I want to group, like that you will see an aggregate, the calculation based on specific type, so close. And I execute the query and I see the number of documents for city, country, and country language. As you can guess, I won't have to count on all the tables, but I have imported all the data. The same way, let's say I want now to query the view, query the data based on the name of the city. This is not something that the tool will create for you because we don't know which type of query you want to do inside your application. So it's quite easy. When you want to do that, you go in your tools, or you can do that using your from your application, and I will add a view to query the city by name. And I will use a map reduce approach to say, look at inside a city, so I can look inside a city, you have a type, city, and you have a name. So what I want is only to index the document when they are a city. So if doc type equals city. So inside Couchbase, we use JavaScript as an indexing engine, but this is something that you see the code you use is very simple. So I will just put in the index because it's where I want to query the name of the city. And what is interesting is you may have country name, you may have a username, also with the attribute names, very flexible schema. But by using a type, I can just ensure that this specific index that I will query contain only the name of the city. So I save that. If I execute the query, I will see all the data. Now I can execute on full data on my cluster. But let's say, for example, I want to see only Paris. As you can guess from my accent, I am from France, so I will show you Paris as a result. So I see Paris, and if I click here, I will see the city itself. So what I have done here, I migrated all the data from MySQL in one single command line, and I have created some views. So one way will be to use this tool, but we also, as part of our ecosystem, I was talking about the integration with Talent. So what I will do here is I will just create another bucket, just to show you the same, more or less the same demonstration inside another environment, so Talent. So it will create another bucket. And let's use Talent now. So I have installed the tool. I have created the basic job to do that, but I will explain you basically what it does. So using the different connectors you have inside Talent, you have many, many of them. As you can see, about database, you have many different type of database. You have Couchbase as part of the NoSQL database, and in this case, MySQL. But you can also use that to connect to other kind of system, okay? So I have dropped the MySQL input to input the data in the job and output the data inside Couchbase. So what I do here is I just connect to my MySQL instance, select a specific query, map the schema to specific types, so I can say what the schema is, and I can even add some field and generate some fields. The same way, for the Couchbase part, I will say where is my cluster, which bucket I want to use. So here I will use Talent for this demonstration. And the same way, you will choose how you want in the JSON document, how do you map your schema coming from your database into a JSON document. And you can add some information if needed. So when this is done, so connected to Talent, information about the connection to Couchbase, connection to MySQL, and now I can run the job. So the job will connect to MySQL, get the row, push it inside Couchbase. So if we go now inside Couchbase, and we see that, so now in the talent bucket, I have more or less the same things that I have created before. So you see all your country, or all your cities in this case, inside the database. So the big difference between using talent or a simple Java code or strict is you can use talent to do a lot more complex mapping operations. So you can do aggregation of multiple tabs in one single JSON document. You can capture data coming from your MySQL or coming from your ERP and put that inside Couchbase as a document. So as you can see, migrating the data is not a problem. This is not something that is complex to do. Also, something that is quite interesting inside the talent integration, you can do incremental migration. So if I run, I can say start the same job, but start at this specific row, like that all the new information that has been inserted inside the database could be captured and pushed to the NoSQL engine, kind of keeping your data up to date. So as a conclusion, and just before the question, we see that it's interesting to move to NoSQL for scalability and flexibility. In my demonstration, I show you two or three things. One of them is I was on a 3-node cluster, and I can add many nodes as I want. Flexibility, because you can switch the schema based on your application. One of the most complex parts being the design of your document. Focus on your application logic first to see what will be the best design for your documents. Migrating the data, it's not a problem. I think for me, it's really, really not a problem. We just did using the command line tool. I've migrating a 5 GB database in a few minutes and starting to look at the data and creating an application at the top of that really, really quickly. In addition, for you, I have put some information about some interesting resources. So the talent connector on the Couchbase importer, but also a very interesting example, especially for Java developer, that has been done by somebody in the community that use as a Java pet store. So this is a sample app from Java EE that where they migrate the application from SQL, JPA, so Java Persistent API, to Couchbase, explaining the different steps. So it's more or less what I explained in the slide, but based on a concrete example of this is my entity, this is a document that I will store, and when I want to write code, this is the code that I have to change to make it from a pure JPA relational database model to a more NoSQL and flexible way, like for example, get a specific, save a specific customer login information and so on. So thanks for this. So I am open to questions, and do not forget that installing Couchbase is few minutes. Just download, click, it's done. So you can start to work with your NoSQL and JSON database.
Thank you, Tag. This is a great presentation indeed. So we have really a lot of questions, and I know we are already 1 hour into the session, but I hope you can stick around for some of these questions. And for those that we're not able to answer live, we will follow up in the next couple of days offline. So let's start with the first question from Ray. So you mentioned that people use Couchbase as a caching tier. How would you compare Couchbase to Memcached?
So this question is very interesting. Let me just, to answer the question, the best way, you go to couchbase.com, memcached. Like that, you will find some information. And how do you compare it? So first of all, we use internally the same protocol. That means you can switch your existing instance application from Memcache to Couchbase. And what it will give you distributed Memcache with a very advanced console to know exactly what happened and so on. So distributed and replicated cache. So if you lose some nodes, you don't lose the data of the cache. You will never start with a cold cache. It's as easy as Memcache with more information, more feature. So remember, just couchbase.com/memcached, you will have many information.
And okay, I'm trying to go pretty quickly, but I want to cover as many questions as possible. So how do you deal with different schemas at the application level?
So it's so if you look at, I don't know if the question is different schema because you have a product that is a bike and a product that is a shoe. So in this case, it's purely your application that have to know that based on the type or something. So it's something you code inside your application. And we have even a customer, an insurance company in Norway, that is building dynamically the form based on the schema they receive from the database, based on the documents they receive inside the from the database. Or if you are talking about different schema in terms of versioning, so you have the version 1 of your database that have a schema with 4 fields, and now you migrate to version 1.1 of your application, and you want to deal with that. So for the first question, I said it's really part of your application. For the multiple version of your application, and I am not talking about version of documents, but really version of schema, what we see a lot people doing, and I would like to have time to write a small paper on sample about that, but what they do quite often, either in each document or in a reference document, they can put some version. This kind of information that will be very technical, or app version, let's call it. And in this case, when they see a new version to the document, they will apply specific routine coming from their code. So once again, a lot is part of the way you will code your application. But you have different strategy, for example, putting a version number inside the document that will help you to say, okay, this document has to be migrated to the version 1.1 or 1.2. It's what I use, for example, with views and queries in my application when I develop them. If you look at some of my GitHub apps, you will see that it's the kind of approach I do. I have a specific version number inside my database. Hope that it answers your question.
Great. We have a question that came from many users. Maybe you can answer in a quick way, even though it's a very long question, very long answer. So how do you compare Couchbase? How does Couchbase differentiate from other NoSQL database like Mongo or Cassandra?
So we are I'm trying to, so you have a very technical answer. That is the way we do partitioning and querying, and the way we do consistency of the data. If you look at Cassandra, by default, the data won't be consistent. So you have to, the application have to read for you. It's not something you have to deal with as a developer, but the runtime will do it. For example, when you get a document out of the database, it will check multiple replicas to say, is it the correct and latest and greatest version of my document, or not document in this case, because it's the column oriented, but latest and greatest version of my entity. Same with Mongo. In our approach, what we have, and this is for performance and latency reason, to guarantee that we have the fastest database, we have one single active version of document in the cluster. The replicas are only here for failover. That means when anybody in the database, anybody in the application is accessing or setting a new document or a document, it will always be the same version for everybody. So this makes access to the data very fast. And also, we believe as a developer, it's easier to deal with this than we have to deal with the consistency of the data. But in this case, what happens is we have to have some very smart clients, a Java client, PHP client, and so on. They have a lot of intelligence to know on which not to write. In terms of, to be really honest, I will say that today our queries and view engine, it's probably less powerful than what you can do with Mongo, but in the same time, we focus on being sure that we have predictable performance. When you have written your views and you have a large cluster and you change your topology of the cluster, you will keep the same performance. You will keep the same latency to access the data. And this is one of the reasons we don't support ad hoc queries, something that is supported inside Mongo. That is probably great on a small data set, but it's something you should never use in a large cluster with a large volume of data. You don't want to do full scan of your data on all the nodes. But in the same time, what we are working on right now, so this is something that I will show you quickly. You do query.couchbase, and you will see the query language we are building for the next release of Couchbase. So it's something that's available as a developer preview that allow you to do very complex query now with Couchbase. So we are to specifically solve this, where we know that we are the fastest, and we have a very flexible way of managing the cluster, a very simple way to add and remove node to the cluster. We did some work, and we need some work on the query engine, something that we do today, and you can even test it online. But it's another topic, and we will probably have webinars on this part. Also, for all of you, if you are looking to evaluate different databases, you have to keep in mind that it has to be easy to do in development, so installation, configuration for developers, but also how much work do I need to manage and maintain my database in production. For example, what we have inside Couchbase that is used and very powerful, it's a very powerful and rich administration console. And all the stuff you see, the numbers, the statistics you see on the cluster about how do you access data and so on, it's available in the console, it's available in the UI. So easy administration and easy configuration. If I want to add new node to the cluster, just click here, add some nodes, no impact on the application performance. This is not the case of all the NoSQL engine. So don't look only as a developer, look it as a system administrator, and monitoring, backup and restore, and so on.
Thank you, Tag. I know we are very late, but I want to answer 2 more questions, maybe in a very quick way. So what happens when data doesn't fit in memory?
So as you can see, I have a hard time to give short answers. But so the thing is, what we put is, we are a database. So not all the data are in memory. And all the data are on disk. And we put the data in memory when we need them. If we need more space in memory, we will remove the data from the memory and replace by somebody else, something by another document, as soon as we know that this document is saved on disk. But we keep something in memory all the time. It is the key of the document and the metadata of the document. Not the document itself, not the value itself. The value itself is moving on out of the cache depending on the application requirement. But the keys and metadata stays always in memory. And once again, this is for latency and performance, because we want to be sure that when you try to access the data, if the data exists, it has to be fast. If the data has to say, I didn't find this key in memory, so I don't know if the document exists, or I have to check on disk. So we do that immediately in memory. So for you, your application, you just have to size the cluster to be sure that you can have all keys in memory, and then the document plus space for your documents. And remember that adding new nodes or configuring your cluster, your bucket, you can tune the memory as much as you want. If I want to add more memory to this cluster, just do this. If I have enough room, I will be able to add. So moving from a 300 megabyte cluster for my data to 300. It's really a cache, managing the cache, but the data are on disk. Remember, we are a database.
Thank you, Tag. Last question. I think this is a pretty quick one. So why not storing JSON in a relational document, in a relational database?
So you can for sure use your relational database as a simple key value store. So a primary key and JSON document as a blob or a club. First of all, I'm not sure you will be able to query the JSON document itself. I know that some databases are doing it, but most of them, they have not been built for that. But I think that if it's only a question of flexibility of the schema, yes, you can work this way. But in the same time, you still need the cache at the top of it. That's something Couchbase is giving you for free. But the way I see it, the most important way, I will say, is the way we do partitioning and clustering. If you look at this, I have a 3-node cluster where data are partitioned. If you want to do exactly that with your relational database, you need a good DBA. You can do a replicate cluster when you have all nodes with all the data, but here I really have 33% of the data on each node, so the load of the data, the load of the query, the way I deal with the power of my machines, it's really distributed on 3 nodes, so you don't need very expensive machines.
Great, thank you, Tag. I think with this we need to close our session. I want to just remind everybody to download Couchbase at couchbase.com download, so you can try what Tag showed today. Also, we're going to have other webinars. In particular, next week we have a webinar called Getting Started with Couchbase App Development, and I encourage anyone who is interested in app development to register for the webinar at couchbase.com/webinars. With this, I close the webinar and the session. I thank Tag for his great presentation, and I hope to see you guys at the next webinar. Thank you.
Thank you. Goodbye.